Okay, continuing with number 14, you're being given a table. It's actually an experiment that they went out into the field. They had a question about how often people check their portfolios. So they went out into the field and asked this question. And there were categories of people who check their portfolio daily, weekly, monthly, a couple times a year, and don't track it at all. So the question of interest here is, out of the 1,005 people that they asked this question to, how many of them answered that they check them daily? Because that's the probability that they're interested in here. Remember that a probability is a fraction. Total number of items in the experiment, people in this case, will go on the bottom. And then the question of interest is the people that check their portfolios daily. That goes on the top. So this is the probability in a fractional sense, 237 over 1,005. And then when you put that into your calculator, top divided by bottom, you get a decimal fraction, or decimal representation, which is equivalent to this fraction. So the answer would be choice C. They've already done the work for you, so I'm not going to do the work. And as I was mentioning, when they collect the results in a live experiment where they've gone out and asked the question to many, many people, or conducted a certain type of event many, many times and collected the results of what happens during each and every trial, that would be the sign of an empirical probability when you're looking at a table like this of collected results. When you are not looking at a table of collected results, that would be called a theoretical probability. So number 17, which refers to just rolling the die, but not rolling it over and over and over again, and then actually recording the results of what happens each time. Notice that they've not given you that. You're just theorizing as to what the outcome is going to be of actually rolling a 5. So there are 6 different outcomes for number 16. So we're going to skip 14. The work was already done. 15, we discussed the characteristics of an empirical probability, the table. In 16, there are 6 faces on a dice, and only one of them has a 5. So that would be the fractional probability. They didn't ask you for a decimal or anything, so that's all you need to do for that one. For number 17, it says in the previous question, what type of probability? Again, I was discussing that in number 16, there's no table for this probability, just theorizing that you had a 1 out of 6 chance of rolling a 5. So that makes it a theoretical probability as opposed to the empirical probability, which is signified by a table full of results. Number 18, they've asked for the perimeter, so you're just going to add all the sides. You don't need a formula anytime you're doing perimeter. So let's see, the 7 occurs twice, so I'll just go ahead and add that in twice. Then I'll add in the 10. It doesn't matter in what order you add these. Then I'll add in the 5. When you're doing perimeter, the units are linear. So this is going to be 14 centimeters plus 10 plus 5. So this would be 24 and 5, 29 centimeters. For number 19, you're asked for the circumference of a circle. You need a formula for that. One way to get circumference is 2 times pi times r. If all they're giving you is the radius, in this case, this would be the preferable way to do it, which is equivalent to this. It's just more convenient in this case because they're actually giving you a diameter. Okay, in this problem, they ask you to use 3.14 for pi. I'm using this formula, so it's 3.14. I put that in for pi times the diameter, and the diameter is given as 30 meters. Okay, this does not say what to round to, so I'm going to give the exact answer, which would be 3.14 times 30, 94.2. The units are first degree. Circumference is considered like perimeter. You're going just around the edges. If you were doing area, then the units would be second degree. But here it's just, you have meters to the first degree, meters to the first degree in your answer. In problem number 20, you are finding the area of a circle. That always helps. Oops. And in the picture, you are given a radius of 4.8. The formula, you're going to need all the formulas for area based on their shape. For a circle, it's pi times r squared. They ask you to use 3.14 for pi. And for the radius is 4.8. And then the formula says to square it. So you can put this in the calculator. Don't forget to attach a square to the 4.8. So putting that in the calculator. And then it also says in this problem, round to the nearest whole unit. So 4.8 squared times 3.14, I get 72.3456. For area, the units are centimeters squared. Always square units. Don't put the square on the number, put it on the unit. It says rounded to the nearest whole number. This is closer to 72 than it is to 73. So here's the answer to the nearest whole number. Problem 21. Problem 21, it says to find the mode. So you have the number 5, which occurs twice. Then you have the number 8, which occurs 1, 2, 3 times. Then you have the number 2, that occurs 1, 2 times. Then you have the number 9, which only occurs once. Then you have the number 3, which only occurs once. 5s we already did, 8s we already did, 2s we already did. So the one that occurs the most often is the number 8. So therefore the mode is 8. Okay, and that would be choice D. Okay, in problem 22, you're being asked to find the mean, which just means you're going to add all the numbers, 9 plus 1 plus 3 plus 8. You don't have to put them in any specific order, plus 3 plus 8 again, plus 0 plus 0. Now, even the zeros count as items, which affect your denominator. So there's 1, 2, 3, 4, 5, 6, 7, 8 items here. And when you add them up, you get plus 19. Okay, so you get 32 when you add up all the numbers on the top, divided by 8. So the answer is 4. That's called the mean. And this is a multiple choice question, which was A. Choice A was this answer. And that completes up through number 22.